A wall of wind near 180 miles an hour is closing on 200,000 Americans this morning. Super Typhoon Bavi has reached the top of the scale, one of the strongest storms on Earth this year, and it is aimed straight at the small islands of the northern Marianas. These same islands took a direct hit from another Category 5 just 3 months ago. By the end of this video, you will understand what this morning's pass could do, and why no one can say how strong Bavi really is. Right now, as you are watching this, one of the most powerful storms on the planet this year is grinding directly toward a cluster of small American islands in the open Pacific, and there is nothing anyone can do to move it, to slow it, or turn it away. Super Typhoon Bavi has climbed to the very top of the scale. Its sustained winds have reached somewhere in the range of 175 to 180 miles per hour. Its central pressure has fallen to around 901 millibars, one of the lowest readings anywhere on Earth this year. Its gusts have been estimated near 200 miles per hour. By the operational numbers used by the United States warning agencies, this is a high-end Category 5 super typhoon, and it is the third Category 5 storm to form anywhere on the planet in 2026. The reason this is an emergency and not just a number on a map comes down to where the storm is going. Bavi is not spinning harmlessly out over open water. Yesterday it reached its peak strength, and this morning its core is threading between the islands of Guam and Saipan in the northern Marianas, with the eye passing over or just south of Tinian and Saipan. These are United States soil. About 200,000 American citizens and nationals live directly in the path. If you were following this story here 2 days ago, you already know the setup, because we tracked Bavi when it was still exploding upward and a typhoon watch had just gone up. What was a forecast then is now reality. The storm hit the top of the scale, and it is nearly on top of the people it was aimed at. Everything that follows in the next 20 minutes serves one question. What does a direct pass by a peak Category 5 actually mean for these islands? And will anyone even know how strong it truly was until it is already over them? Let me walk you through exactly what we are looking at. Bavi did not arrive at this strength gradually. It got here fast, and the speed of that climb is part of the story. The storm crossed the Category 5 threshold on July 3rd with winds near 160 miles per hour. Over the next 2 days, as it moved across the western North Pacific, it kept intensifying. An early fix yesterday placed it near 166 miles per hour with a pressure around 919 millibars. By later in the day, the pressure had fallen further to that roughly 901 millibar peak, and the winds had climbed into the 175 to 180 mile per hour range. To give that pressure some meaning, the lower a storm's central pressure falls, the more violently the surrounding air rushes inward to fill the void, and readings below 910 millibars sit in the territory of only the most extreme storms the planet produces. A reading near 901 puts Bavi among a small handful of the strongest systems anywhere on Earth in any given year, and it reached that mark in a matter of days. To put that climb in plain terms, the official threshold for what forecasters call rapid intensification is an increase of at least 30 knots, or about 35 miles per hour, in a single 24-hour period. Bavi met that bar and then blew past it. Machine learning forecast systems, the newer artificial intelligence models that now run alongside the traditional ones, put roughly a 60% probability on Bavi topping 180 miles per hour at its peak. The official forecast from the United States Warning Center pegged the crest near 175 miles per hour, followed by a slow weakening trend as the storm approaches and crosses the island chain. Here is the detail that matters most, and it is the one people cling to for false comfort. Even with that expected weakening, Bavi is forecast to still be a Category 5 at its closest pass, with winds near 165 miles per hour as the eye reaches the islands. A storm dropping from 180 down to 165 is not a storm that has become safe. It is a catastrophic storm that is very slightly less catastrophic. When the winds arrive over Tinian, Saipan, and Rota this morning, they will still be strong enough to level buildings. The weakening trend is real, but it is the difference between the top of the scale and just below it, and both ends of that range are the kind of wind that erases what it touches. The track is what turns a strong storm into a targeted one. Forecasters expected Bavi's closest approach to Saipan and Rota around 8 o'clock this morning, local Chamorro time, with the center then passing between Guam and Saipan through the rest of the morning. The guidance has clustered the core of the storm over or just south of Tinian and Saipan, which puts those two islands in the most dangerous position of all, with Rota and Guam sitting on the storm's dangerous flank. In a system this powerful, the difference between a direct eye passage and a near miss is measured in a few miles, And right now, the models are drawing that line straight across populated ground. Typhoon warnings are in effect for all 4 of the main islands: Guam, Rota, Tinian, and Saipan. That is the highest level of alert these communities issue, and it means destructive winds are not a possibility but an expectation. Local Homeland Security and Civil Defense offices have been pushing out preparation guidance for days. The islands run on a graduated readiness scale called the Tropical Cyclone Condition of Readiness, or TCCOR, which steps down from a level 4, when destructive winds are still days away, all the way to a level 1, when those winds are hours out or already arriving. As Bavi has closed in, the islands have been walking down that ladder toward the bottom rung. The timing is cruel in its own way, because it compresses everything. These are not places where 200,000 people can simply get in cars and drive inland to safety. There is no inland. There is no elsewhere. When a storm like this is forecast to arrive within hours, the window to board up, stock water, and get into the strongest available shelter closes almost immediately. By the time the outer bands are lashing the coast, the decisions have all been made, and everyone is simply waiting to see where the eye actually goes. This morning, that waiting is happening in real time, and the eye is arriving. Let me be specific about what these islands are facing, because the phrase Category 5 gets used so often that it can lose its meaning. The most intense winds around Bavi's core could exceed 175 miles per hour. That is enough for catastrophic structural damage, the kind that peels roofs off concrete buildings and completely destroys older or wood frame construction. Wind at that speed does not just break things. It turns loose debris, sheet metal, timber, vehicles, into projectiles moving faster than a car on a highway. At 175 miles per hour and above, ordinary engineering standards stop being a reliable guide, because most buildings are simply not designed to take that kind of load. Reinforced concrete structures may hold their walls but lose their roofs, their windows, and everything inside. Anything less than concrete, older homes, wood framing, metal sheds, can be stripped down to a bare slab in a field of debris. This is why the type of building you shelter in becomes, quite literally, a survival factor. The water may be the bigger threat, and it comes from 2 directions at once. From above, rainfall totals of 12 to 20 inches are possible as the storm passes, and on steep island terrain, that much water in that little time means flash flooding and landslides. Flash flood warnings were already up across Guam, Rota, Saipan, and Tinian yesterday, with 3 to 4 inches already on the ground before the core even arrived. From the ocean side, forecasters were tracking open water waves of 25 to 35 feet, with the potential to reach 45 feet, driving life-threatening coastal inundation along exposed shorelines. On a low coastline, that is water high enough to swallow the first floor of a building. Then there's the aftermath, which for an island is a category of disaster all its own. When the winds finally ease, the islands are left with the predictable cascade. The power grid down, water systems failed, roads blocked by debris and landslides, and the airport and seaport shut. On a small, isolated island in the middle of the Pacific, those closures do not just mean inconvenience. They mean that help, water, fuel, and medical supplies cannot easily get in, and the people who rode out the storm are cut off from the outside world for days or longer. The storm is the acute event. The isolation that follows is the slow one, and it is often what turns a survivable night into a humanitarian problem that stretches into weeks. It is worth slowing down on who is actually in this storm's path, because the human scale is the whole point. About 200,000 United States citizens and nationals live across these islands. Roughly 153,000 of them on Guam and about 47,000 across the Commonwealth of the Northern Mariana Islands. These are not remote outposts with a handful of researchers. They are full communities, with schools, hospitals, families, and homes, sitting on small pieces of land in the open Western Pacific. That geography is exactly what makes them so exposed. On a large landmass, a Category 5 weakens as it moves inland, and people can shelter dozens or hundreds of miles from the coast. Here, the entire island is the coast. There is no interior to retreat to, no high ground far enough from the water, no neighboring county to evacuate toward. When the eye wall of a peak Category 5 passes directly over an island a few miles wide, the whole population experiences the worst of the storm at more or less the same time. That is close to the worst realistic scenario that exists for a populated place, and it is the scenario unfolding this morning. Emergency planners describe this kind of event as a whole-of-island impact, where there is no unaffected zone to stage a rescue from, no safe corner to funnel people toward, and no way to bring in outside help until the storm is fully passed. Every resource these islands have to get through the next several hours is already on the islands right now. This is why forecasters and emergency managers have been so blunt in their language and why the readiness ladder matters so much. The margin for error on an island is almost nothing. A decision made an hour too late, a shelter that turns out to be too weak, a road that floods before people can reach safety. Any of those can be the difference between a hard night and a fatal one. 200,000 people are, right now, finding out which side of that line they are on. They are finding out together in the same few hours as one storm passes over all of them at once. Here is the part of this story that pushes it from a disaster into something almost unbelievable. This is not the first Category 5 to hit these exact islands this year. Back in April, only about 3 months ago, Super Typhoon Sinlaku struck the same island group as a Category 5, with worst-case winds assessed near 180 miles per hour, gusts around 220, and a pressure near 888 millibars, aimed at Rota, Tinian, and Saipan. The same islands, the same people, a top-of-the-scale storm twice in a single season. Think about what that actually means on the ground. Parts of these communities are still repairing the damage from the first storm. Roofs that were torn off in April may only just have been replaced. Power and water systems that took a beating are only recently back to normal. Trees that were stripped bare are only beginning to recover. And now, before the wounds from Sinlaku have fully closed, a second Category 5 is passing over the top of them. For any one small population to face two of the most powerful storms on Earth within roughly 90 days is statistically punishing and, in human terms, almost unfair. That back-to-back reality is not a side note. It is the single most important thing to understand about why Bavi's worst case is so severe. A community hit by one Category 5 is a community in crisis. A community hit by a second one before it has recovered from the first is a community whose defenses, its buildings, its supplies, its emergency crews, its sheer resilience have already been drawn down. The damage does not add, it multiplies. Emergency supplies stockpiled for one storm may have already been spent on the first. The crews expected to respond are the same people who are themselves exhausted and, in some cases, displaced. And the sheer psychological weight of facing a second top-of-scale storm this soon after the last one is its own kind of burden, one that never shows up in any wind measurement. When you hear that Bavi is bearing down on the Marianas, remember that it is landing on ground that was already knocked flat once this year, and that is what makes this morning so frightening. You may be wondering how a storm gets this strong in the first place. And the answer is the ocean. A tropical cyclone is a heat engine. It runs on the difference between a warm sea surface and the cold air high above it, converting that gap into wind. The most a storm can theoretically reach in a given environment is called its maximum potential intensity. And the Philippine Sea, where Bavi exploded upward, offered close to a perfect setup. Sea surface temperatures around 29 to 31 degrees Celsius, a thick reservoir of warm water beneath the surface so the storm could not cool itself by churning low vertical wind shear to tear it apart, and strong outflow up top to vent it. That is the full recipe for rapid intensification, and Bavi took it. Sitting behind that warm ocean is a larger signal. The tropical Pacific has strengthened into El Niño, with the main index now reading near plus 0.98, up sharply from the roughly plus 0.48, near neutral value of just days earlier. El Niño tends to enhance western and central Pacific storm activity and loads the ocean heat reservoir these systems feed on. It does not cause any single storm, but it stacks the deck towards stronger and more frequent extremes. And as the broader ocean warms, the ceiling on what these storms can reach climbs with it. Bavi is not a hypothetical about the future. It is that rising ceiling expressed as a real storm over real people this morning. And now the genuinely unsettling part. There is no routine hurricane hunter aircraft flying into storms in the western Pacific the way there is in the Atlantic. Almost everything we know about Bavi's strength comes from reading satellite images using a pattern matching method called the Dvorak technique, which infers wind speed from how the storm looks from space. That means every number I have given you carries a built-in margin of uncertainty, and no one will have a direct measurement of the core as it crosses the islands. The uncertainty runs both ways, which is the frightening part. The true peak could be weaker than advertised, or it could be stronger. And residents could be bracing for a number that undersells what actually arrives. That gap is also why the online claims write themselves. Every time a storm this powerful takes aim at people, someone insists it was steered or manufactured by some secret program. The problem is energy. A mature typhoon releases power on the order of 100 trillion to a quadrillion watts, and nothing built by human hands comes close to creating or steering that. There is no hidden hand here. There is a warm ocean, a steering current, and a heat engine doing exactly what physics says it will. Everything now comes down to geometry and timing. The difference between a direct catastrophe and a survivable near miss for a small island can be a wobble of 20 or 30 miles in the track, and the exact timing of what is called an eye wall replacement cycle, the process where a mature storm swaps its inner eye wall for an outer one, briefly spreading out and sometimes easing its peak winds. If Bavi's inner eye wall passes directly over Rota, Tinian, or Saipan at full strength, those islands take the complete 175-mile-per-hour core. If a replacement happens to be underway as it arrives, the peak winds may be a little lower but spread across a wider area. Both outcomes are dangerous. The wild card is which one plays out, and that is being decided in the next few hours. It is worth keeping the scale honest, because the real story does not need exaggeration. The all-time benchmark for these storms is Typhoon Tip, back in 1979, which bottomed out near 870 millibars with winds around 190 miles per hour. Bavi, near 901 millibars, is an elite Category 5, but it has not broken that record, and the most extreme early model runs that flirted with even lower pressures did not verify. As a measure of what a direct hit costs the region, Super Typhoon Pongsona in 2002 did roughly $730 million in damage to Guam alone. Bavi is being measured against that kind of history this morning. So here is what to watch for as the day unfolds. Watch whether the eye tracks a little north or a little south, because that wobble decides which islands take the core. Watch for the first reports once communication is restored, because with the airport and ports closed, the true picture of the damage may not emerge for a day or more. And watch the intensity as the storm pulls away, because the same weakening trend that offers the islands a sliver of relief will define how quickly recovery can begin. A storm that pulls away fast and keeps losing strength gives crews a chance to move in within a day. A storm that lingers, or that leaves catastrophic damage to the airport and the seaports, can stretch the isolation and the danger well past the moment the eye has gone. The islands have hours, not days. The storm is at or near its maximum. A population that survived a Category 5 in April is being asked to do it again before dawn has fully broken. We will be tracking this closely as the reports come in, and we will bring you the picture the moment it becomes clear.